Manager in the Central American Institute of Public Administration, and I will be the person who will accompany the teacher this morning to today's session entitled Tariff Systems. You're enjoying a course offered thanks to the support of the GEF Group Plus project, whose purpose is to provide knowledge and provide the space for the co-creation of water and sanitation solutions in the wider Caribbean region. The GEF Group Plus is a collaborative project funded by the Global Environment Facility and complemented by the Inter-American Development Bank and the United Nations Environment Program in 18 countries of the wider Caribbean region. The GEF Group Plus project offers innovative, nature-based solutions to mitigate the effects of untreated wastewater on the environment and public health. The Central American Institute of Public Administration is an institution that specializes in the education and training of human resources at local, national, and regional levels. So it's a pleasure for us to be the institution in charge of facilitating this learning space. And now, the facilitator for today is Jesus Vidalon. He is a civil engineer from the Pontifical Catholic University of Peru with an MBA from ESNAN University and doctoral studies in administration from ESADE Barcelona. He has been Vice Minister of Housing and Urbanism and Head of Cabinet of Advisors of the Presidency of the Council of Ministers and the Ministry of Housing, Construction and Sanitation in Peru. So, Jesus, welcome today. In this session, it is called Tariff System, so the time is yours.
Thank you, Diego, and good morning to all the participants, and thanks also for the time you are devoting for this presentation. I am really very glad to share to you some ideas and some information about wastewater reuse pricing, which is a very challenging topic because its level of development is still incipient, not only in our countries, but also in countries such as Spain, USA, Israel, which have achieved very good progress in wastewater treatment and wastewater reuse. And the main issue is that it's not easy, it's very difficult to establish an approach for wastewater reuse pricing uh, because it depends on many factors. No? Just to mention some of them. Number one, the availability of water resources, which varies from region to region, varies by season, and also is becoming less predictable because of climate change. No? Number two, the type of reuse which are suitable for each region. Number three, the level of water quality required for each type of reuse. And it's more complex item because we have many parameters and some specific level of the standard of each parameter is needed for each reuse. No? And also, not less important, the level of profitability of the activity where we are developing the reuse, no? Which is totally connected with the willingness to pay for the reuse. No? And many other factors, including the size of the intervention, the size of the project, because as you understand, it's not the same to develop a project for 10 liters per second than a project for 3 or 5 cubic meters per second. Then we have many challenges. That's why, as an initial a conclusion, we have to say that the best way for pricing wastewater reuse should definitely depends on the exact reality, you know, the real situation we face in each case. I will share the presentation in order to start talking about the main part of this meeting. Okay, this is the content of the presentation. I'm going to stop after each section, but please feel free to interrupt me as needed in order to make some precisions or extend the explanation on a specific topic. Okay, the first section is devoted to answer a question. No? Is it worth reusing wastewater? And the answer is yes, but under one condition. No? And the general condition is that benefits are greater than costs. This is the basic condition. But as you know, when you determine benefits and costs, we need to establish a unit of analysis, and I mean a perspective to calculate benefits and costs. And then the next question is for whom? And the answer is uh, for society. This is the critical condition to promote a reuse project. If we are sure that the project is good for society, then we can make all the arrangements in order to concrete, to execute the project, regardless if we can charge or not charge to reusers, regardless of how much we can definitely charge to the reuser for wastewater. But besides that, we also need to be sure that the project is good for the company or entity that is going to develop the project. For example, if we are talking about the water utility, which is in charge of the development of the project, and also the project needs to be good for wastewater reusers. But the assessment is different. The main question we need to answer is if it is if a wastewater reuse is good for the society. Then we will have two types of project evaluation. First one, social evaluation. In this case, we need to establish costs and benefits from the point of view of society, as I said before. And taking into account the value of money over time, we need to establish the social net present value. And if the social net present value is greater than zero, we can consider that the project is good for the country and must be executed. This is a very important thing we need to be present when we are talking about wastewater reuse. But besides that, we have the private assessment. In this case, we need to establish to determine the costs and benefits from the point of view of the companies or entities that develop the project. If you are talking about the water and sanitation utility, we need to establish which are the real costs that the company need to assume in order to concrete the project. And again, we need to establish the private, in this case, the private net present value of, and if the NPV is uh, greater than zero, the company can run the project. Okay, let's talk a bit about costs and benefits from the social point of view. In this slide, we can see some of the benefits of wastewater reuse from the social perspective. Uh, I just need to mention some of them. To start, I have to say that we need to consider incremental benefits. If we are talking about a greenfield project, a new wastewater treatment plant, we need to consider all the benefits. But if we already have a wastewater treatment plant, we need to think just about incremental benefits. But maybe the most important thing is that benefits for the release of fresh water are very high when we are talking about areas of a high scarcity of water. Uh, because the government can have avoided costs, very high avoided costs in construction of dams, transfer, and maybe all the actors also have avoided costs of groundwater extraction. This is very important because it represents the cost of the opportunity cost for water and generates very high benefits for the society. We have another social benefits, and maybe I also want to mention more reliability in the supply of wastewater because if we reuse water, we can have a fixed flow and permanent supply throughout the year, which is also valuable for reusers, especially in agriculture and livestock and other activities. And finally, we can have also benefits of byproducts like such as sludge, gas, and others. Let's continue. Now we will talk about social cost of wastewater reuse. And also they depend on the type of reuse, but in general, we can have the following. Additional investment costs for wastewater treatment. Maybe we have a wastewater treatment plant and we need to install additional modules of trains of treatment, for example, for filtration or disinfection in order to have the standards of quality we require for the reuse. We obviously need to consider these additional costs, not only about investment, but also about operation and maintenance. We also need to consider the installation of new infrastructure for water distribution to reach the point of reuse. We need some additional, we need to include some additional costs. And something we need to consider when we are talking about social costs, I mean costs following the social perspective, the society perspective, is that sometimes we need to make some correction to the market prices if we have some distortion of the real values. No, for example, if we have currency or labor prices subsidy, then we need to eliminate this effect in order to have the real cost of the resources we are applying to the reuse. Okay, let's continue. Then, after to determine social benefits and social costs, we can establish the final result of the assessment, right? In this case, we need to calculate, as I told you, the social net present value, and the criteria will be if social NPV is greater than 0, the project can go ahead. If the social NPV is minor than 0, the project does not run. It means that the project is not good for the society because we are talking about social assessment. No? In this case, this is a definite result. If our project has a negative social NPV, the project shouldn't go ahead. This evaluation, this assessment is not easy. No? It's difficult to establish the monetary quantification of benefits and social costs. But fortunately, there are many cases, very easy to identify, where we can find out which will be the final result. No? For example, in areas with water scarcity, always the social NPV will be greater than 0. Then if you are analyzing an area in our country which has scarcity, permanent scarcity of water, or seasonal scarcity of water, we can be sure that the social NPV will be greater than 0. Then we don't need to make this assessment for each project. Even I know you will be a specific training also in social evaluation, but we don't need to do it for each project. No? Maybe one national agency can establish some criteria to easily allows us to determine if the project will be social profitable or not. No? Then, when we have scarcity, reuse projects must be executed because they are profitable for society. This is very important. And we can have a conclusion here. No? Projects with this condition are good regardless how much we can charge to the users, because this is another question we should answer in next steps, but this is the real analysis we need to do in order to make the decision for promoting wastewater treatment, wastewater reuse projects. Okay, just a summary. We have here some summary. No? If we have scarcity of water, permanent or seasonal, the water value will be very high, and then definitely a wastewater reuse project will be socially profitable. Then all projects should be promoted. This is the decision. No? But to make them real is not enough that the project is good for society. No? It's necessary also to ensure that they are suitable also for the companies or entities that build and operate them, and also for reusers. No? That's why we need to analyze also private costs and private benefits in order to ensure that we can complete the project. But the main condition is if the project is profitable for society. After, we can do many arrangements in order to guarantee also the benefits for all the actors which intervene in the project. I will stop here just for a minute in order to know if you have any consultation.
Thank you, Jesus. Does anyone has any question? In this session, we have Erwin Flores, Hugo Rancharan, and Renee Jackson.
Okay, I think I can continue, right?
I think
Maybe,
Hugo,
yes, please.
Yeah, good morning. Just a
sorry,
little short. The previous slide that you mentioned, so that is say as water scarcity goes about, then the rate of wastewater or the cost of the tariff of wastewater would go up or would remain the same for countries that experience water scarcity and that do use reuse wastewater as a means of putting back that into the environment. No?
Okay,
Irina.
Yes, I'm sorry, this is interpreter. Could you repeat the question again because you were breaking up?
Yeah, for countries that have water scarcity and the tariff for wastewater, it would be higher, right, as per your previous slide. You understand?
Not really.
Irina.
You mean that for countries that have a higher level of scarcity, uh,
Yes.
their rate would be, what do you mean that part? Like the last part?
If you could just show the previous slide, I could probably get my point across.
Ah, okay, okay.
Okay. Let me to share the slide.
Yes, in that one, the higher water value, meaning that the water would have a much higher value in terms of that for water scarcity, right? That is what it's saying here.
Exactly. Eh, is my microphone open, right?
Yes.
Yeah. Okay. Yes. This reflects the cost of opportunity to have water. No. because if we have scarcity in some area, it's not the same in each region of the country. We can have some areas in the country with a structural scarcity. We can have some areas in our country with seasonal scarcity, but each cases, we need to make some infrastructure works in order to guarantee the water availability for long term, right? Then the high water of value is meaning the economic value of water, the opportunity cost to have water if we don't reuse, no? And usually we need to construct dams, we need to transfer water from other basins, we need to impulse the use of underground water, and it's not always possible because also the level of underground water could be reduced. And this is a concept of opportunity cost of water in areas where we have scarcity. You know? The way for estimation it is maybe to establish what infrastructure works we need to develop. We need to consider the investment and the operation cost of maintenance of this future infrastructure to calculate the net present value, and we need to have an estimation of the costs for cubic meters we will have if we don't reuse the water.
All right, thanks.
Okay, perfect. Okay, maybe I can continue, right?
Yes, let's go.
Okay, after we have determined that the project is good for the society, we now need to establish private cost and private benefits. And in this case, just to do it easily, is easier, we will consider the case of a water utility that executes and operates the project. In this case, the private costs will be the investment costs and operation and maintenance associated to the additional treatment of the required wastewater. As I said before, for example, if we need to install a new treatment train to make the filtration and also the disinfection, maybe UV disinfection of the water in order to get the sanitary standard. No? This additional investment and this additional cost of an operation should be considered in the evaluation. We also need to consider the cost of storage, pumping, conduction to get the reuse area. These are more related, directly related with the reuse, right? After that, we have to consider the private benefits. And in this case, we are thinking about what incomes will have the utility. No? First of all, the revenue from wastewater use. We are talking about tariffs of other use income. Also, the utility can have avoid costs. Uh, in example, there are some cases in our region where the utilities have delivered the wastewater, but before the wastewater treatment plant, I mean raw wastewater, and the reuser has assumed all the investment and the operation and maintenance costs for the treatment. Then the water utility has many very important about the costs. Also, as we can see in the next slides, usually it is very difficult to have an approach of total cost recovery in wastewater use. Then we'll need maybe state co-financing at national, regional, local level. And finally, we can have contributions from other entities. In this case, we also, in order to find out if the project is good for the for the company, we need to make a final assessment. No? But one interesting thing I want to establish here is that the co-financing of the government and other levels of the national government or other levels of government will be frequent because it's not possible to recover all the costs in projects of wastewater reuse. This is an example, some statistics from the European Union, and we can see that the national government, the regional government, talking about the European Union, also some private capital, and in addition, some financing from water tariffs need to be joined in order to get the total financing of a reuse project. It's not then we are not depending only on tariffs. We can charge to the user. This is the main idea I want to establish here. Okay, then we need to complete the private assessment of wastewater reuse, and we will do the same. We need to calculate the net present value and the benefits and costs, and considering the private perspective. And once again, the decision criteria will be, there's a mistake here, NPV is greater than 0, the project runs. It is possible in some type of projects. For example, reusing large-scale agriculture, large-scale livestock, or mining or industry. There are some projects, some type of activities which can recover all the costs, all investment and operation and maintenance costs, but it's not frequent. We need to be conscious of that. No? But one interesting thing is that if the project has a net present value minor to 0, obviously the project does not run. But considering that the project is socially profitable, maybe we need to make some arrangements, and we need to collect some subsidies of some co-financing from other entities in order to impulse the project, to promote the project, because we have determined that the project is profitable for society. Then this conclusion, the NPV minor to 0 from the private point of view, is not definitive to make a decision because the project is profitable for the society. And as I showed in the last slide, we maybe will need a national, international co-financing for the project. Okay, as a conclusion, if we have scarcity, the value, the economic value, the opportunity cost of water will be high. Then definitely, even if we do not have the opportunity to make the quantitative evaluation, we can be sure that the project will be socially profitable. And then the conclusion will be that all projects should be promoted. But we need to take some prevention. For example, in some cases, we need to establish a reserve. It could be environmental flow or ecological flow. It could be some use for drinking water if we are in an area with high scarcity. And maybe we also have some general interest reuse. For example, if we need to recharge the aquifer, or if we need to irrigate some recreational areas in small towns and other kind of uses. But after that, we will have two scenarios. First one, if we have private demand with high profitability, as I told you, we are talking about maybe large scale agriculture and livestock or mining or some industrial process. The reusers can assume all cost of the reuse. I mean the additional treatment, investment, the additional treatment cost of operation and maintenance, also the distribution, storage, and pumping to reach the area of reuse. But maybe in some cases, and this is very interesting thing, taking into account that in that area the economic value of water is very high, maybe they can also assume, they can also could be willing to pay more for the resources, for the water. And we need to consider in these cases the possibility of charge not only direct costs related to the reuse, but also some costs related to the resource, to the water. We will talk more about it in the next slide. This is the first case. And the second case is that we don't have profitable private demand. But as I told, taking into account that we have already determined that the project is socially profitable, we can make some arrangements in order to concrete the project. No? For example, the reusers can partially assume the costs. It depends on the ability to pay and also the willingness to pay. But exceptionally, we can allocate some portion of the cost also to drinking water and sewer users. There is a principle which is used in Europe and maybe USA also, which is the polluters polluters pay. That implies that domestic users, which are responsible in a way for some part of the pollution, also can contribute to the payment of the reuse. There are specific conditions for doing that. We need to discuss. It's not an easy topic, but it is possible also. And maybe this is the most important. The state, the government, can also co-finance the project in order to concrete the reuse of wastewater, taking into account that we have already established that it is good for society. Next. I don't know if you have any question, please. Maybe I can continue. Or,
no, we have a question of Rini Jackson.
Okay, perfect.
Go ahead.
Hi, morning.
Hi.
Can you hear
Good
me?
morning. Yes, we can hear you.
Yes, my apologies. My connection is a bit weak this morning, so I'm missing a bit of the presentation. So I'm not too sure if I would have missed it. But what I want to know is if a country has a large quantity of the resource available, so it's not necessarily scarce.
Okay, yeah, it's very interesting
Is
question.
unable to, if the, sorry?
Okay, I think I understand the question. Maybe I can answer. Okay, not exactly, no? It depends. For example, we are working in the Caribbean area of Colombia now, and everyone considers that they have a lot of water, and it's real. But when we start the deeper analysis, we can see that even they have a lot of water, maybe 8 or 9 months uh, over throughout the year, there are 3 or 4 months where they don't have enough water for agriculture, for livestock, and others. No? And then we have determined in one project pilot that also it is possible and it is feasible to develop a wastewater reuse project. But as I said in the previous slides, I have determined the situation where we don't need to make the assessment because it's obviously we will have a project which is socially profitable. But in other cases, I mean, if we don't have a very clear situation, we need to establish evaluation, the assessment. Maybe some agency, some national agency could be in charge of establish where areas are definitely profitable from the social perspective and where areas we need to develop a deeper assessment in order to make a decision. But usually, taking into account the context of climate change, the increasing pollution, the increasing demand, this is very the possibilities for have for having a positive result in a social assessment is very high.
Okay, thanks. I think I got your answer.
Okay, excellent. Okay, let's continue.
Yes, let's go.
Jesus, I think your microphone.
Jesus, your microphone is off.
Oh, excuse me. I will share again the slide. Okay, we will start talking about components of wastewater reuse tariffs. And first of all, we are talking about components related to the processes. First of all, we have additional treatment investment. If we need to install additional treatment modules in order, for example, to make the filtration or disinfection of water, we will have investment costs additional, and we will have also additional costs of operation and maintenance, no? Which are very important and maybe are the most related to the reuse because it are related to the additional processes we need to develop in order to have the standard of quality we require for reuse. Additionally, as I said in the previous slides, we need maybe to storage, to pump, or to conduct the water to the area for use, and we have additional costs. And finally, we can have administration and marketing, maybe administration and commercialization costs, in order to ensure that the reuse is well managed. These all additional costs are related to process. And one question is if we also need to charge uh, some fees related to the water resource, right? This is a very difficult question in some cases. Then, if we are talking about scarcity, about opportunity cost, maybe we should also charge some fees related to the water, the resource, no? Then, if we are delivering raw wastewater to a third party, which will be in charge of the reuse, or if we are delivering treated wastewater to a third party in order to be reused, maybe we should think about how much can we, in this case, the water and sanitation utility, for this resource, no? And we will try to answer some, to have some answer for this in next slide. Next slide. Okay, maybe the most frequent approach for wastewater user reuse pricing is the cost of service approach. It's very simple. You only need to consider all the costs related to the processes we need to develop to get the not only the quality, but also the delivery of the wastewater treatment for the reuse, right? In this case, we need to charge the costs of the concepts actually assumed by the company, by the utility in this case, no? And it depends also on the point of delivery and other conditions, right? In this case, we can have two alternatives: a single volumetric charge for the wastewater, or maybe we also can use a mixed fee approach. I mean, a fixed price for investments and variable charge for operation and maintenance. In this case, I mean, in the cost of service approach, we need to consider that there is no charge for the resource. This is a typical case of Colombia, where it's not possible to charge for the water, only for the services uh, related to the reuse. No? And other things we need to consider is that in many cases, full cost recovery is not possible to be achieved. That's why we need some co-financing from the state, no, public, national government, and local governments, and even in some cases, the users from the water and sanitation service under specific conditions. Okay, some small example. Uh, you have in the slide the information for the small case. We will have a new wastewater treatment plant, UASB, financed by the national government and delivered to the water and sanitation utility for the operation. This is the investment will be developed by the national government. It was designed considering the standards required for the reuse. In this case, includes filtration system and ultraviolet disinfection system. What happened here is that the farmers have not enough profitable crops. Then we do not have a very profitable demand. We have a demand with limited profitability. In addition, we have some information about the investment costs, the unit investment cost of the wastewater treatment plant. Investment are 0.3 US dollars per cubic meters, including some portion for the filtration and disinfection. And also we have the operation and maintenance costs, and also some information about the administration and commercialization costs, which are estimated at 16% of O&M costs. And the idea is to estimate, to calculate the fee we can charge to reusers based on the cost of the service criteria, which have been analyzed in the previous slides. It's a very simple example. Then we will have here all the concepts we talked about. The first one, additional treatment investment, was not considered because it is assumed by the state. It's a decision, right? Because even the state has subsidized this investment. Maybe we can decide to recover some portion of it. No, it depends on the profitability, the willingness to pay for reusers from the user and others. And besides that, we have the cost of O&M of the additional treatment. We need to charge this. This is the amount. And also we will have the investment and O&M of storage, pumping, and conduction. But the information establishes that this is the reuser in charge of them. Then we don't need to charge it. And we need to charge administration and commercialization costs because they will be assumed by the water utility. In this case, we can charge to the user the cost of operation and additional treatment, plus administration and commercialization costs, And the result is what you are seeing in the slide. It's very simple. You have to remember that in this case, we are not charging nothing for the water resource, and we are not recovering the investment. No? This is very frequent situation. No? And we can consider that if we can recover the cost of operation and maintenance, we can have a kind of sustainable project, but we should assess the possibility to recover some of the investment and some money related to the water resource. Okay, and now we have a market approach. The first scheme, the first approach was cost of service approach. Now we have a market approach. We can apply it when we have profitable, private profitable projects in order to try to recover more, especially some money related to the water resource. But it's not frequent. We need to establish the real situation where we can apply this approach. I will put some initial considerations of this approach. Okay, in this case, we will have evaluation by use. Then the most important thing is that this approach considers the profitability of the activity in which the wastewater is used. This is the most important thing. And the key thing is what portion of this profitability the reuser is willing to give up in order to ensure water availability resources for the future. No? This is the only important thing. No? We are putting here some procedures, some detailed information. We will have the slides. But the most important thing is that we need to answer what portion, what percentage of the profitability of the reuser could be used to ensure the water for the future. And we have two cases. No? We can deliver untreated water, and we can deliver treated water, and the calculation has some difference in each case. The important thing is that this scheme can allow us to capture at least partially the value of the resource, no? Which reflects the scarcity, now also the nutrients, and this procedure allow us to have some collection related to the resource. This is not exact procedure. This is an estimation. That's why usually we use it just to establish a reference price, a base price, to develop market procedures, no? Such as auctions, tenders, in order to have a better approach to the market price of the water. We will have another case, very simple case also. We will have in the slide the information. There is a wastewater treatment plant, but it is in poor condition and without capacity to meet demand. Then the treatment is not effective. The quality of the effluent is bad. We have available flow for reuse of 100 liters per second, and we are thinking about reuse in agriculture, no? But large-scale agriculture for exportations. And the situation is that the farmers no longer have a supply of water. This is a real case we have in Peru, in an area in southern country. Another condition is that the reuser will have the obligation to treat the wastewater and reach the established standards for the reuse. And some important information is provided here. I want to talk about this. We are considering the perspective of the water utility. No? And in this case, where we are including real information, actual information of a Peruvian project, where we have avoided costs to install a new wastewater treatment plant, which are 4.8 million, talking about investment, and 2.8 million, talking about the operation costs. Then we will have $7.6 million in avoided costs, even if the user don't pay anything for the wastewater. No? And also we have savings in wastewater discharges fees. Okay, we will explain in this slide all the methodology, and we will go ahead faster because of time. But in this slide, I will try to explain all the methodology. Okay, we need to establish the profitability of the business by unit. I mean, US dollars per cubic meter. And the question is how portion of this profitability the user is willing to give up in order to ensure the water. No? There are some additional steps. For example, we need to consider the incremental cost to have the water. We will assume some costs for the wastewater treatment, investment and operation and maintenance, and this cost is not considered in the previous profitability data, then we need to consider this cost as a negative factor, right? After that, if we have the net margin of production by unit, expressed in dollars per cubic meter, and we can apply a factor which represents the proportion of the net margin allocated to water, we can have a referential price for the water resource. No? This is the methodology. It's easy. No? We start with the profitability, and after that we establish the percentage of this profitability. We can allocate to water to apply the factor, and we can have a referential the price for wastewater. Then I will go ahead. I'm not developing each slide because it has many information, but you can review after that all the numbers, the numeric example, which is content in the presentation. The first one is to determine the profitability. We need to consider the price, and the farm gate price and the production costs to determine the profitability. It is shown in this slide. In this case, the result is 0.66 US dollar per cubic meter. After that, we have to establish the incremental cost for the wastewater treatment, which was not considered in the previous profitability. And the result is 0.16 US dollar per cubic meter. As a step 3, we can determine the net production margin. I mean, the rentability, the profitability is but after reducing the incremental cost to have water, no, which is the net production margin. In this case, we have 0.5 US dollar per cubic meter, no, as a final result, a net margin we can use to determine the referential cost for water. And finally, we have to apply to this net margin a factor, in this case 9%, which represents the proportion of the profitability the user could be willing to give up in order to ensure the water for the future. No? This is very referential. In the case of this project in Peru, we need to analyze the cost structure of the competitors the agro-exportation business. Because in Peru, the price of water is very low, then we consider cost structure in Chile for a similar company in order to don't reduce the competitiveness of the Peruvian company. No? We use 9%. We apply this percentage to the net margin, and the final costs for the raw wastewater was $0.045 per cubic meter. But we need to consider that this is an additional cost because the main obligation of the reuser is to install and operate a new wastewater treatment plant, and all this investment and all these operational costs are avoided costs for the water utility. Okay, as a conclusion of this small case, we will have that wastewater reuser must assume all the treatment costs, investment, and operation, as I said. They are estimated at $0.27 per cubic meter, plus a payment for the raw wastewater, which we have calculated just referentially in $0.05 per cubic meter. But this is just an estimation. No? The most frequent use for this methodology is just to establish references values for an action or for a bid in order to have a real market approximation, real market approach to establish the volume. In this case, in this action, the reuser pay 15 or 16% more than the referential price. Finally, we have to consider that the water utility has avoided costs of at least $7.6 million. That implies that even if we don't charge any amount to the user, the project is good for the company. No? Now the company has additional incomes, but even if we don't charge any amount to the user, the project is good for the company. And it determines some additional questions. No? For example, what's the destination of the money received and the impact of the savings on the users of the water utility. Maybe in the next presentation, Diego can share some ideas and information about this question. Okay, just to finish the presentation, you can see in the slide another tariff approaches for wastewater reuse. One of them is distribution of all costs among all users of water. It's interesting, but in this case, it's impossible to consider the difference between quality of users, profitability of activities, and others. No? And the second one, which implies to consider an increase of the supply of water and allocate the responsibilities by volume for all users, no? Not only but wastewater reusers, but also the water and sanitation users. In this case, we have the same problem. No? It's not possible to consider different qualities, different types of reuse, different of profitability of activities in which you are reuse the water. And there are another practical approaches. For example, establish the price of the wastewater for use as a percentage of the price of drinking water, or to establish the price of wastewater for use as equal of the price of drinking water and others. No? As I told at the beginning, as I said at the beginning, this topic is still in development, and we think we need to work a lot as in our countries in order to have a more precise and more suitable approach for wastewater reuse pricing. Okay, thank you. I don't know if there is another question. If not, we are finishing the presentation. Just to remembering that the most important thing in when we are talking to reuse is to put the wastewater reuse tariffs in the context of circular economy, integrated management of water resources, and we can promote reuse projects regardless the amount we can charge to the reusers. Okay.
Thank you very much, Jesus. Does anyone have any question? Okay, we are going to pass to our second presentation today, our second expert. His name is Diego Fernandez. How are you, Diego?
Hi, good day. Good day to all people here.
Hi, Diego. Diego Fernandez is an economist from Universidad del Valle. He's a specialist in data analysis from Universidad de La Salle in Colombia and master in public policy and regulation from the Torquato de Tella Institute in Buenos Aires. He is an international consultant with more than 30 years of public service experience. He has advised government entities and water and sanitation companies in 12 Latin American countries from Mexico to Argentina. He has also worked in Mozambique, Sierra Leone, and Jordan. He is frequently consultant to the IDB, World Bank, CAF, ECLAC, and GTC. His main areas of work are the design of public policies, national investment plans, regulation, design of tariff methodologies, and private participation in the water and sewerage sectors. Hello, Diego. Welcome. Thank you for being here, and the time is yours.
Thank you. Okay, and now we are going to see the possible tariff impact of the water reuse in the user of the water service. This is the table of contents. We are going to see the economical, technical, and political characteristics of the water
Diego,
Yeah.
you are not sharing the presentation.
Oh, sorry.
Or
Share. Oh, sorry.
okay, it's okay now.
Okay, sorry. Of contents. We are going to see the economical, technical, and political characteristics of the water and sanitation service, which is the tariff definition process, alternatives for calculation of the service cost. After that, we are going to enter in the reuse, seeing the initial considerations for the reuse, impact of the reuse on tariff components of the water tariffs, incentives that can be included in the tariff framework, in the water tariff framework to incentive the reuse of the water, of the wastewater. Okay, go with the economical, technical, and political characteristics of the water and sanitation service. The first is total recognition that we are in front of a natural monopoly. The water, in fact, the wastewater or the water service is without substitutes. Is better than in a single locality exists only one local producer. In some countries like England, they are promoting the simultaneous service of in one locality, but this is not a good idea. Is in almost all cases, this will be more costly for the users or for the society to have more than one water provider in one locality. And maybe the most important characteristics of the water service is that it's a meritorious good. This is a good or service that has a high health and environmental service externalities. All we know the impacts of a bad water service in the health of the children's. The service is essential for the form of social organization in the cities, especially, but almost in all localities. In almost all countries, exists a national policy for universal service access. This is a human right, and all we accept that all inhabitants of any country should have access to water service. So the water service is the most important utility service of all that this service depends on this service depends the life of the people. It is a local good that is important. However, the importance of the water service, except for some environmental externalities, the characteristics of the water and sewer service only affect the local users. One bad service in one locality, discontinuity of the water, bad quality of the water, bad quality of the wastewater service affect directly and almost only to the local users of that locality. Don't affect the country, don't affect the region. And there are few areas that with network that are regionals, that is means that go from one locality to another locality are strains that exist but are strains, and almost in all countries each locality has his own network and and the administration, good or bad administration of that names affect exactly directly the local people are not the people in other localities of the country. However, the water have a national scope. The responsibility to guarantee the human right to or universal access to that service are shared between local, regional, and national governments. All governments don't matter of the level, national or regional, have to work with local authorities to guarantee the water service. What are the principal characteristics of the water service? In terms of economic vision. In the water and sewer service, there are minimum administrative and technical plans. That means that is not affordable for small systems to survive with water rates when they are serving less than 2,000, around 2,000, 2,500 of users. Why happened that? Because the cost of water provide, the wastewater, water and wastewater provide have a minimum cost. You need an administrative plan, you need a technical staff, and you need some vehicles. You have to incur some costs that are almost fixed or has a minimum that is not possible to cover with charges to small localities. However, in fact, it's estimated that the economies of scales have some limits too. Many people think that the economies of scale are permanent, and that if you have a more bigger water provider, you can have a fewer average cost, but that is not the case. the reality is that in some points around a locality of 600,000 inhabitants, that economies of scales begins to disappear, and the reason is because the cost of works in some localities in some big cities begins to increase very important for many reasons. From the salaries begins to increase, the cost of intervene of civil wars in the streets is more costly. So it is not permanent. The economies of scale are not increasing permanently. However, in smaller towns is maybe better to provide, not to be local, but to be regional. Regional service providers exist in some countries in Latin America, maybe as we can see in Chile, or in some small countries like Honduras or especially Salvador, there are only one national provider, and this is the same case for Panama, by example. So when we have small localities, it's better to have a regional provider. One bigger producer have a better chance to access inputs to, and especially to the credit system. And this is very important because the water needs credit, need access to the capital system to finance his big investments. What is the tariff definition process for this service? We need to consider that we have to define the tariff for the future. We need to define tariffs that permit the water company, the utility company, to provide the service in the long run. So we ever that we go to define the tariff of one company, we begins with the projection of demand, that is users and consumers of current and the future. We begin with the information of the commercial system that have the current users by category, the current consumptions by category. We need some information about the future population growth rate, the future population coverage goals, and define some analysis horizon that is used to be 5 years, but can be 10 years or 15 years. No more than that is recommendable. But to use 5 years is the most used system to define the future tariff. 5 years have to be used in almost all regulatory process in almost all the regulators of the world, of the water in the world. When we have this information, we project the demand, which will be the population and the volume that we have to produce in the future. And so we have the consume and users of the future, and the users for category 2. After we have the demands projection, we go to the cost projection. The cost projection depends in some parts of the quality goals, the pressure, continuity, service outage, expansion, goals of expansion of the service, goals of losses, and we have of the previous slide, future users, future consumption, and maybe in some cases are necessary to to define some specific investments commitment that can be the local government or the utility by self. That is, by example, they define to construct the wastewater treatment plant, and this can be based on specific investment goals. When we have this information, we process the investment calculation cost. This calculation of the cost can be done by cost function that is used, by example, in Peru or in Chile in the past. Past behavior. With past behavior, we refer to the real cost that the water company present in the recent years, or projections of the company with his own definitions. And we calculate the operational cost. The calculation of the operational cost of one company can be done by the model company, that is a special company that it don't exist in reality, but reflect the best company that can be provide the service in one locality. That this model company, in fact, is used in many service, not only in water. In fact, in water is used in some cases, but is not the common. And in benchmarking, this is to compare the cost of one company with the cost of another companies, or another options to define the cost, the operational cost. And after that, we have as output the annual investment required over in the horizon of the time horizon defined at the beginning of this exercise. And we have the operational cost for each year of the time horizon. We have no, in fact, the cost after this exercise. We have the investment cost and the operational cost for the period, as I say before, the 5 year is the more used horizon time to define tariffs. After we have this exercise, we pass to one intermediate but very necessary step, that is the determination of the discount rate. We are talking about the cost of the future of many years, 5 years of the future cost. So we need to define a discount rate in order to calculate and to be able to compare the cost of different years of that projection. Is not the same $1,000 in the year 1 that $1,000 in the year 5. It's clear that for common knowledge, one people will say, "Oh, that is exactly the same." But from the financial point of view, the $1,000 in the first year have a cost larger than the 5 cost, that the same amount of money in the year 5. So it's necessary to define a discount rate. How we define the cost rate? We have to define the cost of the public sources. The cost of the public sources can be the rate that the government or the utility obtain loans in the market, in the capital market, or can be a defined a capital cost of the public sources. Like, by example, in Colombia, the government defined by one norm from the National Department of Planning the cost of the public source. And this is the case in Peru too, by example. Or can be used in fact the cost of the loans, or some leverage level of capital of the company. With that information, we define the discount rate. The most used system is the weighted average cost of capital, or some public discount rate. But as I say, the weighted average cost of capital is the most used process to determine for the determination of the discount rates, and we obtain the discount rate for you to be used to the calculation of the water rates. With this information, from the previous slide, we have the annual administrative and operational costs, we have the annual capital requirements, we have the discount rates, we have the projection of demands, and we have to define some or to identify some third-party contribution. That is, after the company have all the costs that is supposed to be encouraged in the next 5 years, the company receive or have the idea that we'll have received some resources from the national government or the local government or the regional government, or some contribution of a company, by example, for a private company. Any contribution have to be taken in account, because that will reduce the cost that we have to recover by the tariffs. And the process is, this is the most important or the principal process of the tariff definitions. This is the income and financial model. This is a little complicated financial model that is used to define the required income, the annual or for the horizon of the projection, the cost in constant prices and in present value of the required income, the required income medium per user, required income medium per cubic meter. In some countries where there are not a classification or user of when all the users, no matter what activity they done, there exists only one tariff. So we can finish the process of water tariff definition here, because we have the medium per cubic meter. But in that countries where there are only one tariff for all people, or where there are fees charged and variable charge, and in fact, almost all countries have fees charged and variable charge and category users, especially in the development, in non-development countries, we have to define the tariff by user classification, by consumption blocks. The input is all the information that we get from the previous exercises in the previous slide, but we have to define the tariff structure. This is, we have users that can be commercial, industrial, residential. In some cases, the residential users have some classification. We can have a high class user, medium class user, low class user, social users. Especially in Latin American countries, is common to use to classify the user in some categories. Some users have subsidy, some users have overprices. So this is the tariff structure, and in this tariff structure we have to define the specific price of the specific charge for each users in this structure. But we in the previous exercise, or in the previous slides, we only get one price. We have the average price per cubic meter, or we have the average price for a user. We have to transform this information in one tariff structure that depends on each country. And as a result, when this exercise has not done for many years, the result is that are necessary important water tariff increases and this maybe need some definition of an implementation plan in order to go from the actual tariff rates to the new tariff rate if these increases are so important. Final, from the point of view of the regulation, or from the point of view of the local government, not from the utility, is necessary, or is a better idea to have some incentives for better service, and the company has the rates and quality parameters and investment commitments. So if we define tariffs to comply some quality parameters or some investment commitments, when the company fails to comply with that qualities or these investment commitment isn't convenient or maybe necessary to define some sanctions or incentive schemes that promote the company to get that goals. That what kind of incentives we can define in the water service. Discount to users for poor service, that is a good idea. Bad quality of water, discount of the service, penalties, what kind of penalties, special audits to be sure that the information that the company is giving is the correct, or when they fails, entonces so some administration action plans in order to promote the company to get the goals, or renegotiation of tariffs, or the contract in case of exist of contract, or in some extreme cases to take possession of the water company when the problems are going very important. So we have now the tariff. That tariffs in fact are independent of the reuse of the water, and we are going to see how we can take in account the reuse or the new cost of the reuse of the wastewater in this tariff. Oh, sorry, I go rapidly from alternatives for calculation of service cost. We say we have defined the cost, but where that information have to come from? We can calculate the cost from the tariffs have a special information for the user, give signals to users about the cost of providing service, give signals to utilities of the viability of providing service, it gives signals to other agents, especially suppliers and lenders, of the feasibility of supplying goods, service, and credit to the provider. See? So the tariffs that are applied for water services have to be very close related with the cost incurred by the water operators. What are the alternatives for calculate that cost? Because we say we have to calculate the cost. We don't say yet how calculate this cost. And this is the case. How we will calculate that cost? The base cost can be a regulated entity on cost, that is the real cost of the company, with some correction of efficiency if in the case of the water company have no good performance. And this is the most used system for regulation the water service in almost all countries in the world, except in Chile. Chile don't we use the regulated entity on cost to define his water rates. And the other base cost can be the simulated or theoretical cost of that regulated entity. What means simulated or theoretical cost. This means that we are not use the regulated entity own cost, but we are going to use some models to define which costs that company have to be incurred. This system is used in almost all the regulation of energy service and gas in most countries in the world, and is the system used in water in the regulation of the water service in Chile, where they use a model company to define the water of the regional companies that exist in that country. They don't use the regulate entity own cost, but the model cost. Which have to be the reference period. The reference period can be the past or can be the future. The past, when we use the past, we say that the provider must recover the cost it incurred in the past. What was your past cost, and in the tariff will permit you to recover that cost. Or if the reference period is the future, the tariff will give the provider the possibility to obtain the income that allowed it to cover the future costs. And this is the recommended system to use the future period as reference. Terms, I said before, we can use short terms to calculate the cost. This is when we say short term, we are referred to 1, 2, or 3 years. But these very short terms can leave out of the analysis large projects that take very years, more than 3 or 4 years to be constructed. In change of that, to take a long term is a good idea. As I say, the most used term to calculate tariff is the future 5 years. But some countries or some regulators think that it's good to use a more long terms. That in some cases they recommend to use, by example, 20 or 30 years. See, but data for the future years when they are far away are very uncertain, and is not recommended to use more than 5 years, or in the extreme case 10 years. We have to be the source of that information for the cost. For the operational and maintenance cost, can be the cash flow of the company and the income statement. But for the infrastructure cost, can be the cash flow, the income statement, or the residual investment. We are going to see that here. What is alternatives based on cash flow? The tariffs will be designed to cover the cash requirement for the provision of the service. So the provider's future cash requirement has to be projected and is intended to cover effective operational costs, administrative and operational and maintenance costs that incur the company, investment payments, how much can have to pay the company for his investment, how much have to pay for interest and for debt repayment. In this methodology, we don't include the depreciation because it's not a part of the cash flow, nor amortization of that asset that don't have depreciation because they are not cash outflow. Investment include all the costs of renovation of existing infrastructure and acquisition or construction of new infrastructure. The credit disbursements that are projected to be received in the projection period enter with a negative sign in the calculation cost. So we project all the payment that company have to be done, and deduce the income that they will receive from credit loans, and this is the cost that we need to recover by the water tariff to be calculated. See? What are the problem with this methodology? That the companies with identical condition and investment projection might result in different tariffs. Why? Because they have a different condition of credit, or they have different condition of cost, of they by decision of the company, especially because they have one credit, one company can have the credit for one term, by example, 10 years. Other company have a credit condition of a repayment period of 15 years, and this go directly to a different tariff. The formula I will not explain too much in this. This is all in present value, but is operational cost, debt serving, investment, and credit and credit received that used to calculate the cost of the service. The second and most used system is the projection of cost based on income statement. The tariff will be designed to cover the cost caused by the provision of the service. The cost caused are not the payments of the company. By example, the depreciation is a cost caused by the service, but it don't require any payment. So the cost causes are those costs that are incurred by provider service, even though they are not paid during the period. See? In this project, we include as cost the depreciation of the assets, the amortization of that assets that are not depreciable, but those existing in the base year and those of the projections. Debt repayment and investment payments are not included as cost. We don't include the debt payment as a cost in this methodology. We don't include the invest payment as cost in this methodology. The interest paid for the loans is used to include, but not exactly in the condition that the company can take that loans, but from one regulated point of view, that is the interest and the interest are part of the cost of the service as a remuneration for the asset that the company has. Why this alternative is the most used? Because regardless of the financial scheme of the company, companies with equal conditions and investment projection will have equal tariffs, because that methodology don't depends on the financial scheme of the company. The formula used is for the cost is the depreciation, the amortization, the administration of operational maintenance costs, plus an asset base times the discount rate. That is the interest or the cost of capital that the system, this methodology will recount to the company for the service. And another alternative is not common, but is used in some countries, is projection based on remaining investment. In fact, in terms of operational and maintenance costs, the methodology is the same as the previous one, but for for the capital cost is not used to include the depreciation, but is used to include the base rate or the investment or the asset in the initial at beginning of the period, plus all the investment that in the company incur in the 5 years period or in the horizon of projection, less, but then is included in the formula as a negative cost the total asset that the company has at the final of that period of projection. So in fact, the depreciation have to be calculated in order to know how much will cost the asset base at the end of the period, but the projection the depreciation in fact don't appear. This is the formula. We have a asset base or the initial value of the infrastructure of the water company. We add for the period of projection all the investment that a company will incur. We include as ever the operational and maintenance costs, and we include in this formula as a negative the cost of capital. This is very important because we have here we have a big cost that is the investment, the value of the initial infrastructure, but we have here at the end of the period as negative the remaining value of that investment. If this is a very short time, these two key zero or key end will be almost the same, but for a 5 years projection will be some difference that come from the investment and the depreciation that don't appear in this formula, but in fact have to be calculated in order to arrive to key end. So we have all the costs. We know the methodology. Now we have some knowledge of the methodology to use that have to be used to calculate the water and wastewater services. What effect have the reuse in these methodologies, or what, in fact, what effect have the reuse cost or the reuse process in that cost that we have calculated or we will calculate it with those methodologies? That depends in some of many things or in some things. The first one is where the delivery of wastewater is required. If the water is required before the wastewater treatment plant, they don't have effect. They can affect the cost of the water company or the wastewater company. And if they is required after the wastewater treatment plant, it can have another effects in the cost of the wastewater company. How the delivery of wastewater is required? It can be required at the current level of treatment. So the user of the wastewater require the wastewater exactly as its actual level of treatment, and this actual level of treatment can be zero directly. The company, as in the ICA case that was explained by Jesus, the water was not treated in any level at all, but at this level was enough of was of great value or have value for the user. But in some cases, the users of the wastewater require some additional treatments. And in this case, this additional treatment can be in charge of the generator of the actual wastewater company, or at expenses of the receiver. That is, the receiver say, okay, I need your wastewater. This wastewater needs some additional treatment, but I will in charge of this additional treatment. Not ever the receiver wants to take the charge to have the responsibility of additional treatment, because can be no be his line of business. By example, some agricultures need water with more treatment, but they don't want to enter in that business. They need that the water company directly give the additional treatment that the wastewater requires, and in this case, say to that company, please be you in charge of this additional treatment. What are the impact of the reuse in this case? Well, we have in some countries like Colombia or Honduras, by example, or includes in the case of or Dominican Republic, we calculate some administrative costs, an average administrative cost, and we calculate this administrative cost as the administrative and business cost without the cost the operational cost, or without the investment cost. We calculate this average administrative cost as the administrative business cost divided by the number of subscriptors to be billed. So if the reuse increase the administrative cost, there will be a higher cost in the numerator without effect in the denominator. So the effect will be to increase this cost. We don't want that this additional cost of the reuse goes to the cost of the water users, water or wastewater users, or residential or commercial. We don't need, or we don't want that this additional cost, the reuse, can increase, go to the users. But so we have to take in account this effect. The second is the operational cost, the average operational cost of the sewerage system. The numerator is the operational cost, including the treatment cost. This is the cost for the sewage service when it's not independent, or when it have included the treatment cost as only one tariff, like is the case for almost all the Latin American cases. In the Latin American countries, we don't have one tariff for sewers and one tariff for treatment, like is used in some countries in the United States. In almost all countries in Latin America, we apply only one tariff for sewers, and that tariff include directly the sewage without treatment, or the sewage with treatment when the treatment exists. So in the numerator, we have the operational cost of the wastewater plus the operational cost of the treatment plants. In the denominator of that formula is the water demand, in some cases corrected by losses. When we enter in the reuse, there are some possibilities that that new activity increase the cost. if additional treatment is required at the expense of the generator, that if the generator have to do some additional treatment, so it's normal that this cost increase, but it's possible to, and this is so important, that when the wastewater company enter to that new activity, have lower costs if the delivery of the receiver before the existing or future wastewater treatment plant. What is the case? If the receiver of the wastewater require the water before the wastewater treatment plant, that new activity don't will increase the cost, but in fact will reduce the cost. Why? Because it's not necessary to treat the water. The water to be treated in the wastewater treatment plants will be reduced, so will reduce the cost. So we have a new activity that can reduce the cost of the wastewater service. And furthermore, can be the case that the water company or the wastewater company has in his investment plan to construct a wastewater treatment plant of some defined capacity, by example, 5 cubic meters per second. But no appears a user of the wastewater that don't require that treatment and require the water before to be used or to be delivered before the future wastewater treatment plant. In this case, this new activity will give the chance to the company to change the dimension of the planned wastewater treatment plant, and we permit reduce not only the investment but the cost of that future treatment plant. In this case, we will have lower costs. That will not affect the denominator of the formula, but we have these two effects. It can increase, but in fact, it can lower the operational cost. And this is the same for the same explanation for the investment costs. The depreciation and annual cost of the capital of the investment can be increased if there are additional treatment required, or it can be reduced because reduce the future investment. So in resume, we have that administrative costs can increase or almost ever will be increased, no matter where the delivery location of the wastewater to be delivered. Or operational costs can be decreased if that cost, if the delivery of the wastewater is before the wastewater treatment plant, or can have no effect if that delivery is after the wastewater treatment plant. And investment costs can decrease if this cost is before the wastewater treatment plant and the treatment plant is not constructed yet, but is a plane, or if the delivery is after the wastewater treatment plant, we will not have any effect. And if the receiver needs additional treatment, and this treatment is in charge of the wastewater company, will increase the cost of operational costs and will increase the investment cost. If that additional treatment is in charge of the receiver, will not have effect in the operational cost and not effect in the investment cost. So,
Diego,
yes,
nada más, disculpame un toque. Ocupamos ir cerrando por aquello.
listo. Okay. So, what we need from the regulator point of view, to prevent that additional cost of the treatment required for the receiver goes to the tariffs of the water users. So we have to establish the obligation of the providers to record in the accounting the cost of the reuse separately, are not allowing the inclusion of reuse cost of the components of the additional cost that the reuse can increase goes to the water system. And finally, we think that is a good idea to give some incentives for the reuse, and is to permit the sharing of the benefits of the reuse between the company, the water company, the wastewater company, and the users, allowing the provider to retain part of the cost saving generated by the reuse. That don't have to transfer all that cost saving to the users, and maybe only enable the revenue generated by the reuse to be subtracted from the cost of the sewer service if the company can have this possibility, but only in terms of incentives. See? That's a very specific, that is the company can change the investment plan, and the providers of the wastewater treatment service can be a special category that in order to promote that they construct the plants, the wastewater treatment plants, as the case of ICA, that was very, very interesting case that presented by Jesus. That is all. Thank you. Thank you very much.
Thank you very much, Diego. Does anyone has any question? Okay. Thank you very much, Diego, for the presentation. Thank you all. We will see you soon in later sessions. Have a good day, everyone. Thank you.
Thank you.
Okay. Have a good day, everyone.